Okay, so this is the first example of an object sliding down an incline. So the first thing you do is draw your incline and draw your object sitting on your incline. And do your free body diagram of everything you know. So here, a block of mass of 2.0 kilograms is placed on a smooth plane. For this smooth plane, for this question, we're going to assume it's frictionless. So we're not going to draw in an FF for this diagram because we're assuming that this plane is frictionless. But we do have our Fn, our Fg, and then you draw your Fg parallel and perpendicular. And that angle there is 15 degrees. So theta. So my theta is equal to 15 degrees. And besides that, I'm only really told the mass. I'm trying to figure out acceleration of the block. Okay, so when we're finding acceleration, we need to use F net of the actual direction of movement. So oh, and I should put Fg parallel here too. Fg parallel. This is my direction of motion. So what I really want to find in order to get acceleration is I need F net parallel. That's what I need to find in order to solve this question. So now I'm going to write out my formula of what I decided was what we made as what F net parallel is. So that was F net parallel is equal to Fg parallel minus Ff. Well, we said that this is frictionless, so Ff is 0 in this problem. So then I can say that F net parallel is equal to Fg parallel. Oh, and I'm going to label this as this is step number 1. Sometimes since there's often 5 or more calculations in these questions, it's good to label this is step 1, this is step 2. I find for me to keep organized, so I'd suggest that would be a good option for you guys as well. Okay, so I've just established what F net is. Okay, so how do I find Fg parallel? Well, let's look at where Fg parallel is on this triangle. Okay, here's Fg parallel. Well, I can solve for Fg using m times g. So this is my second step. Fg is equal to m times g. So Fg is equal to 2.0 kilograms multiplied by 9.81 meters per second squared. So Fg is equal to 19.62 newtons. Then what you can do is you can redraw your triangle, or you can just look at that one there. I often like to redraw my triangle just to make sure it's clear. So this is my Fg. This is Fg perpendicular, and here is Fg parallel. Theta is 15 degrees. 15.62. So if I'm looking to find Fg parallel, that's opposite over hypotenuse. So to solve for Fg parallel, I can go sine of 15 degrees. Oh, and this is step 3. Sine of 15 degrees is equal to Fg parallel over 19.62 newtons. You cross multiply, and so into your calculator you go sine 15 multiplied by 19.62. So FG parallel, then what'd you get?
5.078.
Yeah. Newton. Good. Okay. So now that I have my FG parallel, I can go back here to what I had set up originally. So now this is step 4. If Fnet is equal to FG parallel, then I can just say Fnet parallel is equal to, oops, I wrote 2 T's. Fnet parallel is equal to 5.078 newtons. I'm trying to find acceleration, so A is equal to Fnet parallel divided by m. So A is 5.078 newtons divided by 2.0 kilograms. So if you put that into your calculator, you should get 2.539, etc. meters per second squared. So in sig digs, we need 2 sig digs, and I need to state what direction it's going. Well, we're not given anything like east or west or anything, but we know that it's going down in an incline, so that's our direction. It's just down the incline. So this is 2.5 meters per second squared, comma, down, incline. And that's your final answer. So next it says, how far up the plane was the block released if it took 1.5 seconds to reach the bottom after it was released from rest? So rest means VI is equal to 0 meters per second. T is equal to 1.5 seconds. We know our A, we just found it, is 2.5 meters per second squared. And we're looking for D. So this goes back to our kinematics formulas now. So you check out your formula sheet and see which formula can I use for all of those variables. D equals VIT plus half AT squared. So now you just plug it in. Oh, and VI times T is obviously 0, so it's a little bit more simple. D is half AT squared. So D is equal to half times by 2.5 meters per second squared times by 1.5 squared. D is equal to 2.8 meters. And this isn't displacement, it's just a distance, so 2 sig digs. And no direction needed.